Okay, kids, this is for study goal number something. Study goal number 5. And this is just like class, except the sound quality will hopefully be better. And unlike class, you can pause me at any time. You can go back 10 seconds and repeat what I just said. Might make it easier for you to take notes. It also gives you a chance to come back if there was something that you're arguing with one of your homies when you're studying. You can be like, oh, we'll just check the lecture. So I'm going to start doing more of these again. This is for study goal number 5. And I want to talk about ecological succession. So we've got these super devastating fires locally, happens all the time, and increasingly severe fires throughout California for a variety of reasons. Climate change, forestry practices, humans encroaching on wilderness. We'll talk a lot about that. Gender reveal parties, apparently. So we'll talk a lot about fire and fire management later, but a question that comes up often, it's a big topic for the College Board and it's a big topic for environmentalists in general, is how does nature recover? Disturbances happen all the time. It's not just fires. We have tsunamis naturally. We have hurricanes here and there. Volcanoes erupt, sometimes small volcanoes, sometimes big ones. And so there's this pattern that ecologists have discovered. You can see on the shared screen here that ecologists talk a lot about this pattern, and they always draw these diagrams like the ones that you see on the screen, which go from like rocks to forest, rocks to forest, rocks to forest. And I want to explain a few things about this, and I want to help you out a little bit. One thing that I think is really important for you to put into your notes immediately, right away, up front, is that primary, secondary, tertiary succession, ecological succession in general, nothing to do with size. Before you do anything else, just put it in your notes that this is not small, medium, big plants. If you look at those things I showed you, they're all going from small to medium to large. It's like so generic, and I can understand why that's misleading. We need to be really, really careful here because there are gigantic exceptions. Speaking of gigantic, the largest flowering tree on Earth is an early succession species, the biggest flowering tree. And some of the latest species to return after a disturbance can be some of the smallest flowering plants, like orchids, return very, very late. And so technically, to be precise, it's not small, medium, large, because it can go eucalyptus first, orchids last. It's not small, medium, large. Make sure you have that down first of all. I think that I told you in your notes that I don't like something that your book said. So we're going to break this up, ecological succession, into primary and secondary succession. Secondary succession will be subdivided into early, middle, and late. So it goes primary first, because that's what it means. Secondary, early, middle, and late. And then there's something called tertiary succession, and I'll explain all these terms later. You don't always have primary succession. Primary succession is the building of soil. So some disturbances would leave topsoil. Like if you have a fire that's not super hot, you just get ashes on top of dirt, you would start with secondary succession because you don't have to build soil. If you have a volcano with lava, there's no dirt left. It's just rock. If you have a atomic bomb, atomic bombs require primary succession because atomic bombs are very hot and they burn off all the soil. Sometimes if you have a super gnarly flood, like we're talking like hella tidal wave, in some places you can remove all the topsoil. Really severe flooding and really, really severe major landslides sometimes will expose bedrock. Glaciers can expose bedrock. In those cases, when there's no topsoil, that's what we call primary succession. Your book says life where there was no life before, I think, which is kind of appropriate, but I'd rather it says soil building, the process of building soil. That's primary succession. I don't know if you've ever thought about this, but building soil is really slow. If you leave like a dog bowl out in the backyard for like 2 years and you come back, there will be like the teeniest little hard green crust on the bottom. Maybe you've seen that. Or like an abandoned vehicle, like left out on a farm somewhere. It'll have like a dark green flaky crust. That's the process of building soil. Building soil in large volumes, like on Mount St. Helens after a volcanic eruption that covers like 15 miles, that is really slow. Basically what you're waiting for is in the rain, you'll have little tiny bacteria and little pieces of ash or pollen or dust. We'll talk about this later, but every raindrop has something inside it. That's what made it form. It's called a condensation nucleus. We'll talk about that later. When any raindrop falls, it brings little tiny bits of organic material and life down to the rocks. And you get these little tiny puddles, little microscopic puddles sometimes. If you've seen lava rock, you know it's porous. People use it to like scrub their feet, pumice. So imagine those little tiny pores with like a couple of bacteria swimming around, eating a little bit of pollen or dead skin cell or whatever. As that water evaporates, all that organic material dries up on the bottom. And then the next time it rains, it like rehydrates, like those expanding sponges. And microbes start to decompose that. So imagine this really slow, gradual, cumulative process of rain, expanding organic material, decomposers, rain, decomposers, rain, decomposers. And over thousands of years, you can start to accumulate enough stuff that you could call that soil. Lichens and moss, they can often grow on bare rock. So we call those primary succession species. Everything I said is pretty small, but I gotta remind you, that's just a coincidence. It's because you can't make big stuff without soil. Technically, lichen can be really large side to side. It's just thin. Primary succession is the process of gradually building soil where it was lost before. Meteor hits, burns off all the dirt. Primary succession is going to take a while to build up soil. Volcano goes off, lava, primary succession. It's going to take a while to build up that soil. In some environments, it can be 10,000 years before you've built up enough soil that you can start secondary succession. Secondary succession is once you have soil, and just to be clear, big disturbances can have patches of soil left. So technically, like when Mount St. Helens went off, there was like strips of lava flow that were all primary succession in those spots because there was no soil. And between them, there was these little ribbons of topsoil those little ribbons, because they had soil, started immediately into secondary succession. So those recover faster because there's dirt, right? Like a bird takes a poop and drops a seed, and like stuff can grow because there's dirt. So secondary succession is what on this screen is called intermediate. Secondary succession is stuff that lives in soil. And this is your distinction. Primary, no soil. Once soil has built up, or if soil was left behind, then you can start with secondary succession. Now, most diagrams, remember, be careful, will say small, medium, large. That's just a coincidence. Don't be distracted by that. It's wrong to say small, medium, large. What you really see in these successions, like what's on the screen here, it says annual weeds, perennial weeds, shrubs, aspen, beech, so on. What you really see is a progression of how picky the plants are. So secondary succession is broken up into early, middle, and late, where early is the stuff that's not picky at all. Think about the weeds that will grow like in a parking lot where there's like a crack in the asphalt and weeds start to grow. That's not a picky plant. Like weeds that'll grow like out of your rain gutter, that's just a little bit of soil, right? I've actually seen weeds growing like out of the rain gutter on top of a car. You know, that little tiny groove that's like that deep. In the earliest stages of secondary succession, what you get are what we call in science world generalists. And that's what you would call in just plain old English weeds. These are not picky. They just need like a little spritz of water and a teeny little bit of soil, and they're going for it. These tend to be like a flash in the pan, ecologically speaking. Like the seed will sprout and this thing grows up and it makes seeds and then it's gone. They're just a rapid turnover. And as these start to colonize the area, usually here in Santa Barbara, we would say in the first winter after a fire, you'll get like a bazillion little weeds. Now those will decompose, add more organic material, so they're starting to bulk up the soil fast now. We're not waiting for a dead bacteria to decompose. Now we're waiting for like a big bushweed to decompose. So obviously we're building soil faster, we're cycling more nutrients around, because these early succession species are taking stuff out of the air, they're taking stuff out of the water, they're producing biomass. And as they decompose, they're really bulking up the soil. So in some of these diagrams that I'm showing you on the screen now, you'll actually see succession happening above ground, but soil is getting bigger. And that's a great way to think about it. Here, look, like that. Where you can see starting with rock, it's still rock, and then we're starting to build soil. Remember that soil is built by decomposing organic material. Stuff dies, falls apart, now there's nutrients on the ground, we call that soil. Secondary succession, the early species are the weeds, the generalists. And then, once those are present, think about what happens ecologically. Maybe the soil takes a little longer to dry out because it's shaded by all these weeds. Or maybe the weeds provide wind protection. So in middle secondary succession, you get plants that are a little bit more needy. They need something. Maybe they need shade. right? So they don't dry out. Maybe they need wind protection so they don't get blown over. Maybe they need the soil to stay wet for a longer period of time. But we say these are slightly more specialized because they have a requirement. And as more and more species become present, you're also providing more and more requirements for other species. So around here, some of the classics are grasses come first because they're tough, they're weeds. Then sage needs the insulation and the moisture in the ground. Once you've got sage, then you can block enough wind and build enough depth of soil for oak trees to come. And what's interesting is when you provide the oak trees, a lot of insects can be associated with oak trees, so they will now pollinate the flowers of some stuff that's more picky because it needed those insects. And so here you keep seeing this small, medium, large, but that's not the right way to think about it. Remember all of those relationships. Remember all the relationships between species. We talked about this earlier. That's why I did that lecture. So you'll see the stuff that's not picky at all, a little bit more picky, getting increasingly picky. And so here comes almost that entire lecture with a few more words added in. This is the part where you can pause, take notes, watch this. The distinction between primary and secondary is whether or not you have soil. If you don't have soil, you're going to wait a long ass time. Nuclear bomb, volcano, really, really, really hot fire, glaciers. If you don't have glaciers, like why these rocks are all exposed behind me in my summer photograph. If you don't have soil, you're looking at a long recovery. If you do have soil, like somebody cut down all the trees, like somebody let grazing animals eat all the vegetation. But if you keep the soil, that's less slow. This is why the temperature of a fire is a really big deal. Like whenever they interview an ecologist during these big fires, the ecologist will be like, yeah, it's no big deal. And on the news, they're like, dude, people are dying, houses are burning. And the ecologist will be like, yeah, but it didn't get that hot, so we're okay. This will come right back. Because ecologically speaking, the temperature of the fire matters a bunch. If a fire gets really hot, you can burn the dirt. That's equivalent to a volcano or a nuclear bomb. Atomic bomb. That's a really big deal. Yeah. Primary succession is really tedious. So you just hope that soil is left. A lot of the impacts that humanity has are relatively minor because at least you've left the dirt. You may remember that during the Thomas Fire Montecito mudslides, there was a lot of conversation that some areas of the fire were ecologically benefiting. You just took all the biomass and you made it into ashes. So now plants can put that all back into new life. That's pretty standard in our environment. We're a fire renewal community here, meaning that our ecosystem is renewed by fire. But during the mudslides, some of the topsoil was lost. That storm was so big that soil was lost. That's a really big whoop, really big whoop. Okay. Pioneer species are the first to move in. So after a disturbance, if your first species is on soil, then your pioneer species would be the weeds. If your first species to move in are lichen or whatever, that's the pioneer species. They're just the first ones to move in. Remember that the primary succession species are ones who don't need soil. So we say bacteria, algae in little water droplets. We say lichen or moss that can grow directly on rocks. And secondary succession species are those which do need soil. They're broken up into early, middle, and late. And that writing is really small. So you may want to pause in a minute and expand all of those so that you can read. The generalist weeds come first. The slightly picky go in the middle, and the most specialized go in the end. Just to be clear, eucalyptus is an early secondary succession species because it's not very picky at all. It just needs a little bit of dirt and it can grow. That's giant, but it comes early. Some stuff is super specialized but tiny, like little epiphytic orchids. Those are late secondary succession, even though they're small. The spectrum is not small, medium, large. The spectrum is generalist, kind of picky, very picky, super specialized. Tertiary succession is like building the ecological pyramid on top of the vegetation. So that's all the stuff that shows up, like when the bird moves in, now the snake moves in that eats the bird, now the predatory birds move in last. So that's kind of building your food chain based on that vegetation. That's called tertiary succession. And the climax community is basically when nothing is new anymore. So it's sort of like an undisturbed community. It's like you can't tell anything happened. Like there's really no species missing and everybody's already stabilized among each other. That's called climax community. You can go back and forth with this slideshow as much as you want. Remember this lecture. If you want to come back to this, keep the location in your notes. Otherwise, that's the end of this video lecture. I got to see how to stop. Okay, bye.